Hello everyone, this is Chinnaiah Kalpana here. In this video, we're going to see a problem from partial differential equations. So let's get going. Problem: form the partial differential equation by eliminating the arbitrary constants a and b from 2z equal to x square by a square plus y square by b square. So we are given an equation. We are asked to find partial differential equation by eliminating the constants a and b from the given equation. Right? Let's consider the given equation as equation number 1, where a and b are arbitrary constants and z is a function of x and y, where x and y are independent variables. You can call z as a dependent variable. Let's partially differentiate 1 with respect to x. Firstly, we'll see the detailed process and then later we'll go for the shortcut. Partially differentiating 1 with respect to x. Just apply dou by dou x on both sides of 1. Since we are partially differentiating with respect to x, so we'll treat y as constant. This gives us 2 into partial derivative of z with respect to x, or you can just write it as equal to partial derivative of first term plus partial derivative of second term you can write this as 2 into dou z by dou x equal to constant 1 by a square into dou by dou x of x square. Since you can split x square by a square as 1 by a square into x square, plus partial derivative of constant with respect to x is 0, which gives us, we have a notation, since dou z by dou x equal to p, let's replace dou z by dou x by p. You'll get 2p equal to 1 by a square into partial derivative of x square with respect to x is 2x, right? You can just cancel 2 here itself or take this 2 to RHS, then you'll get p equal to 1 by 2 into 2x by a square, where 2 gets cancelled and you'll get p equal to x by a square, or just bring this x to LHS, you'll get p by x equal to 1 by a square. Consider it as 1. Sorry, 2. Already we have considered the given equation as 1. Now let's partially differentiate 1 with respect to y. Apply dou by dou y on both sides of 1. Since we are partially differentiating with respect to y, so we'll treat x as constant. You can write this as 2 into dou by dou y of z equal to partial derivative first term of RHS plus partial derivative of second term. Which gives us 2 into dou z by dou y equal to partial derivative of a constant with respect to y is 0 plus dou by dou y of, we can split this term as 1 by b square into y square, right? Then 2q equal to, since dou z by dou y equal to q, so we can replace it by q. You'll get 2q equal to constant, that is 1 by b square into partial derivative of y square. Which gives us 2q equal to 1 by b square into partial derivative of y square with respect to y is 2y. Now take this to RHS, you'll get 1 by 2 into 2y by b square, which gives us y by b square, or q equal to y by b square. Bring this y to LHS, you'll get q by y equal to 1 by b square. So you can write this as or 1 by b square equal to q by y. Consider as equation number 3. So you can write equation number 2 as 1 by a square equal to p by x also, right? Fine. Now observe 1, 2 and 3. So by observing 1, 2 and 3, we can say that 1 by a can be replaced by p by x and 1 by b can be replaced by q by y, right? So by substituting 2 and 3 in 1, the arbitrary constants gets eliminated. By substituting 2 and 3 in 1, we get 2z equal to, we have equation 1, right? We have 1, 2z equal to x square by a square plus y square by b square. Now we can write this as 2z equal to, we can split the fraction. We can write it as 1 by a square into x square plus 1 by b square into y square. We can write x square by a square as 1 by a square into x square, and we can write y square by b square as 1 by b square into y square, right? Now substitute 2 and 3 in 1. We get 2z equal to, from 2 you have 1 by a square equal to p by x, right? So just replace it by p by x. You will get p by x into x square plus, from 3 you have 1 by b square equal to q by y. So just replace it by q by y. You will get q by y into y square, where 1x and 1y gets cancelled, and which gives us 2x equal to px plus qy. See, it does not involve any arbitrary constant, and also it is a function, or the equation is of the form f of x, y, z, p, q equal to 0. See, it does not involve any arbitrary constant, and it has z, p, q, p, q, x, y, right? So we got the partial differential equation, which is the required partial differential equation. Now let's see the shortcut. Partially differentiate 1 with respect to x. 2 into dou z by dou x, since we are partially differentiating with respect to x, so while we treat it as constant. 1 by a square into partial derivative of x square with respect to x is 2x plus partial derivative of a constant with respect to x is 0, which gives us 2p equal to 1 by a square into 2x, right? 2 gets cancelled and we'll get p by x equal to 1 by a square, or 1 by a square equal to p by x, which we have considered as equation number 2. Now partially differentiate 1 with respect to y. We get 2 into dou z by dou y equal to partial derivative of a constant with respect to y is 0 plus 1 by b square into partial derivative of y square with respect to y is 2y, which gives us 2q equal to, since dou z by dou y equal to q, 1 by b square into 2y, where 2 gets cancelled, and you'll get q by y equal to 1 by b square, or 1 by b square equal to q by y, which we have considered as equation number 3. Now substitute 2 and 3 in 1. We have 1 . Now using 2 replace p by x, replace 1 by a square by p by x and replace 1 by b square by q by y using 3. You'll get 2z equal to 1 by p by x into x square plus replace 1 by b square using 3, where 1y and 1x gets cancelled, and you'll get 2z equal to px plus qy, which is the required partial differential equation. See, it does not involve any arbitrary constants, and also it is an equation of the form x, y, z, p, q equal to 0. Well, we have seen a problem from partial differential equations in this video. I hope you'll understand. We'll see you in the next video. Until then, bye bye.